The T lymphocytes, which leave the thymus, should not react against self-peptides. They should not attack body cells for the peptides that these body cells typically make. They should be tolerant of self. In the thymus, they are presented with self-peptides, and any which react against self are selected against or destroyed. However, in autoimmune diseases, there are T lymphocytes which react against self, and T helper cells can stimulate B lymphocytes which make antibodies against self. One of the factors is that proteins can be modified after translation. In the endoplasmic reticulum, proteins are folded and additional groups can be added, such as sugar groups, phosphates, or amino acids could be modified. For example, the amino acid arginine can be modified into the amino acid citrulline, which is accomplished by removing an NH group and replacing it with an oxygen. Not only would this potentially make a protein different, not the same as what a T lymphocyte had learned to tolerate, and thus possibly capable of triggering an immune response, but also this change could then alter the way that a protein is folded. So for example, arginine with its positive charge might result in changes to the tertiary structure that citrulline with its neutral charge would not. And so once citrulline replaces arginine, a protein would potentially then fold differently, which could definitely seem as a foreign peptide, unlike the original peptide which the T lymphocytes had learned to tolerate. While it is possible that peripheral tissues post-translationally modify proteins in a way that the training of the lymphocytes in the thymus did not, it is also possible, for example, in the case of diabetes, where autoantibodies are being made against insulin, that T lymphocytes begin to inflame the beta cells of the pancreas. And as a result of this inflammation, the endoplasmic reticulum is placed under oxidative stress, in which case it is more likely to misfold proteins, or under the influence of inflammatory cytokines such as interferon and some interleukins, that the conversion of arginine to citrulline increases, so that it is the result of inflammation which modifies the proteins in a way that they will then be perceived as foreign, which will then cause additional lymphocyte reactions against them. And so thus the number of autoantigens can increase with time. A patient who is only recognizing insulin as foreign may now begin to recognize additional proteins made by the beta cells of the pancreas as foreign. And this is one of the signs of progression from insulinitis to type 1 diabetes, the increase in the number of autoantigens. There is one protein, GRP78, which is known to increase the conversion of arginine to citrulline under the effects of inflammatory signals, and is an autoantigen in type 1 diabetes.